Good morning, students. Today we are going to read the sixth and the last lecture of the current electricity in the subject of physics O levels. So this is a technical topic. So concentrate yourself. We are going to start now. If an electricity meter is inspected, it will be found to have the abbreviation 1 kWh on it. This stands for kilowatt hour. So K stand for kilo, W stand for watt, and A stand for hour. The commercial unit of the electrical energy. It is the energy supplied in 1 hour by a rate of working of 1000 watt. So 1 kilowatt hour is equal to, kilo stand for 1000, so it will be 1000 watt hour. Furthermore, 1000 joule per second for 1 hour. So 1000 watts stands for 1000 joule per second for 1 hour. Now this 1 hour is going to be converted into seconds. So in 1 hour there are 60 minutes, and in 1 minute there are 60 seconds. So 60 into 60. So 1000 into 60 into 60 joules. And this will make 36 00000 joules, or actually this is 1 2 3 4 5 6, so 3.6 megajoules. Okay, here is a question related to the topic. Find the cost of running a 2 kilowatt fire for 3 hours if the cost of electrical energy is 6 pence per kilowatt hour. So look now, total energy consumed will be equal to power multiplied by time. So the power is 2 kilowatt, this is 2, and this is time, that is 3 hours. So this will make 6 kilowatt hour. So the rate is 6 pence per kilowatt hour. So 6 will be multiplied by this 6. So total cost is 6 into 6. That will be equal to 36 pence. Here is another question that will make your concepts even more clear. A lamp is rated at 240 volt, 60 watt. What does this mean? So look now, this means that power consumed by the lamp is 60 watt when the voltage is 240 volt. The second part is calculate the resistance of the filament when the lamp is used. Okay, the formula will be used. P is equal to V square over R. V is 240 and resistance is the requirement, and power given is 60. So P is 60. So from here P is 60, V is 240, and R is the requirement. Calculate the resistance. From here, cross multiplying the values will give you the answer 960 ohm. The next thing that we are going to read in the topic is house electrical installation. The cable bringing the mains electricity supply into a house contains two wires, one of which is live and the other neutral. The neutral wire is earthed at the local transformer substation. So it is the earth potential. At some convenient place inside the house, the main cable enters a scaled box where the live wire is connected to the electricity board's fuse, which are actually coming from the house. On the far side of this box, the power cable enters the meter, and from there it goes to the main fuse box. The fuse box contains separate fuse for each of the lighting circuits, like this one, ring circuit and cooker circuit. In modern installations, the power sockets are tapped off a ring circuit. This cable passes through the various rooms in the house and has both its ends connected to the main supply. Thus, there are two paths by which the current may get to a particular socket, which effectively doubles the capacity of the cable. It can be seen from the figure above that all lights and power switches and fuses are placed in the live side of the supply. So all the switches and cable sockets are placed on the live side of the wire, not on the neutral side. The reason is, if they were in the neutral side, all light and power sockets would remain live when the switches were in the off position. The next topic that we are going to read is the circuit breakers. These are used in the consumer units instead of fuses. There are two types. So, in old ages, fuses were used, and now modern thing in place of the fuse is circuit breaker. The first contains, there are two types. Okay, the first contains an electromagnet which, when the current exceeds the rated value of the circuit breaker, becomes sufficiently strong to separate a pair of the contacts and breaks the circuit. The second type of the residual current circuit breaker compares the current in the live and the neutral wires, and if they differ by even a small amount. So the difference in the live and neutral wire. So the function of this type of the circuit breaker is to note the difference. So if there is even a small difference, it throws open a switch which can be reset when the fault has been corrected. Okay, the next thing that is the other form of the circuit breaker which were used in old times are fuses. So we are going to read now. For safety reasons, all domestic electrical appliances are fused. That is, in at least one place on each circuit, a fuse is fitted, which will blow if a fault develops in this circuit and too great a current passes through it. This arrangement protects the wiring against the possibility of the overheating and setting fire to the house. The main house fuses for the different circuits generally consist of the short lengths of the tinned copper wire fitted into porcelain carriers. These fuses are usually situated under the stairs or in the cupboard, which also contains the electricity meter and electricity board fuse. In addition, items which are separately plugged into power sockets, for example fires, contains a fuse in the plug. This type of the fuse consists of a small glass cartridge with a thin wire through its center. Such a fuse is rated at 2, 5, 10 or 13. So there are three types of the fuse. So this is their rate to suit the appliance to which it is connected. These values will be used in the questions, so learn them: 2, 5, 10 or 13 ampere. For example, the value of the fuse which should be used in the plug of 240 volt 2 kilowatt fire is calculated as follows. Power is equal to voltage multiplied by current. Power is 2 kilovolt, watt, that is 2000. Voltage is 240 volt, current is there. So current will be equal to 2000 over 240. Use the calculator, that will be equal to 8.33. So if this is the current, so 10 ampere fuse will be very suitable. So a 10 ampere fuse would thus be suitable. If a fault develops in the appliance, the fuse in its plug will normally blow rather than the larger one in the main fuse box. This avoids other appliances being put out of action at the same time. So only the particular thing through which the larger current passes through, its fuse will blow, and other things, other appliances will remain on. So this is the advantage of this kind of the fuse. The thickness of the wire used in any fuse is such that it will overheat and melt if the current passes through it exceeds its specified rating by much. Once the wire has melted, the circuit is broken. When a fuse has blown, it is essential that the cause of the fuse blowing is found before it is repaired or replaced and the appliance used again. So it is very necessary to detect the fault before repairing the fuse, because if you repair the fuse without detecting the fault, so the fault may occur again and that may be dangerous. So it is very necessary to detect the fault first and then repair the fuse. Sometimes a fuse blows because the fuse wire is very old. So there are some other reasons for the fuse to get blow. A fuse wire is very old and has become weakened by oxidation, or it can blow due to a fault in the circuit, such as short circuit in the flex where the insulation has worn and frayed. Whatever the fault, it must be found and put right before a new fuse is fitted. So this is the thing which is important. Two other types of the fuse are worth mentioning. An anti-surge fuse is designed not to melt if there is a surge of the current for a very short time. So if the surge of the current is for a very short time, the appliances can withhold this situation, can bear this situation. But if the surge is for a longer time, then the fuse will melt and the circuit will be broken. So look now, an anti-surge fuse is designed not to melt if there is a surge of the current for a very short time, but it is designed to melt if a large current flows for a longer time. A current surge often happens when a circuit is first switched on. The second type is a quick blow fuse. Does just what its name implies. It melts very quickly if a large current flows. The next thing that we are going to read in the lecture is earthing. Besides the live and the neutral wires, all power circuits are provided with a third wire, green and yellow strips, which has been earthed by a good electrical joint to the cold water supply. When an appliance is connected to the circuit, the earth wire provides a low resistance route between the casing of the appliance and the earth. The reason is this is a safeguard to prevent anyone receiving a shock by touching the casing should this become live. Such a danger would arise if the insulation on the live flex had become worn and allowed the live wire to come into contact with the casing of the appliance. So if the live wire comes into contact with the casing and if someone touched that, that may prove fatal. So this is the advantage of earthing. If this happens in a properly earthed appliance, a large current would instantaneously flow to the earth and the fuse would blow, thereby cutting off the supply. Loose connections in plugs are another potential source of the danger to the person. Proper earthing again removes the danger. Parts of many modern appliances, such as the bases of the electric lamps, are made from plastics now. In such cases, there is no need for an earth wire since plastic does not conduct electricity. This method of protection is called double insulation. Here is a question now. Operated on a 240 volt supply, the element of an electric kettle supplies 240,000 joule in 2 minutes. Find the power used. So the formula for power used is W over T, and W is 240,000 joule over time is 2 minutes. So in 1 minute there are 60 seconds. So 2 into 60, that will be 120. Solving it on the calculator will give you 2000 watt. The second part is the current flowing. Okay, the formula will be used. P is equal to VI and I will be equal to P over V. So the P is 2000 watt and V is 240 volt. Solve it on the calculator will give you the answer 8 ampere. The next thing that we are going to going to solve is the element resistance. So R is equal to VI. V is again that is 250 volt and I is at 8 ampere. So solve it on the calculator will give you the answer of the resistance. The next thing is the cost of using the kettle for 2 hours continuously at 4 pence per unit. So look now, energy used in 2 hours is equal to power multiplied by time. So power is 2000 watt multiplied by time is for 2 hours. So this is 4 because 1000 is kilo. So 2 twos are 4. So 4 kilowatt hour. Okay, because the price is 4 pence per unit, so we will multiply 4 with this 4. So 4 into 4 will be 16 pence. The last part is the current rating of the fuse required in the plug. So look now, current in the house is 8 ampere. So 2, 5, 10 and 13 rate fuse are available. So for this current 10 ampere 13 ampere fuse will be suitable. So 2, 5, 10 and 13. I think so 13. Okay. So 13 ampere fuse will be suitable. So this was the lecture, students. Read this lecture again, understand it, learn it, and make your notes. Thank you so much.